Alright, welcome back everybody. This is problem 3 of chapter 10, and we're going to do problem number 56. My gosh, every time I do this, man, this stroke width, which is like a default here. But this is problem 56, and it seems like a fairly short, both 56 and 71 feel like fairly shorter problems compared to the last two we've done, so hopefully we won't be here too long. But yeah, I suggest watching on 2x speed regardless. But yeah, let's go ahead and get started. So 56 reads, calculate the rotational kinetic energy of a 12 kilogram motorcycle wheel if its angular velocity is 120 radians per second and its inner radius is 0.28 meters and outer radius is 0.330 meters. So this looks like a, what is it saying? Looks like a moment of inertia and rotational energy problem. Both these next ones are, I think. But yeah, let's go ahead and refer to our formula sheet for that. So, let's see. So if we go down a little bit, we will find this equation right here. This is going to be used for our rotational kinetic energy. That's what K sub R stands for. In order to find the energy here, we have to know the moment of inertia of the object that's spinning. So that means we have to know the moment of inertia of a ring, and it's a ring because it gives us two different radiuses, an inner and outer. So if we go back, the problem stated calculate the rotational kinetic energy. So of a 12 kilogram motorcycle wheel if its angular velocity is 120 radians per second and its inner radius is 0.28 meters and its outer radius is 0.33 meters. So let's go ahead and write everything down first. So M is 12 kilograms and its angular velocity is 120. Whoops. Its angular velocity equals 120 radians per second. And its inner radius, so R sub I, maybe I'll put I in, I don't know. We'll just leave it as I. Its inner radius is 0.280 meters. And its R outer radius is 0.330 meters. Sorry if you can hear my computer, it's kind of loud right now. But yeah, we have everything we need. The only thing we don't have on the formula sheet is the moment of inertia of a ring. And that is one of the things you have to be able to remember for the exam. So for a ring, the moment of inertia is I equals 1/2 mass times R inner squared, and then plus R outer squared. And remember when he was talking about it, he was saying how if the inner radius, if that gets smaller and smaller and smaller, it approaches 0, and then this equation becomes 1/2 R squared, which is what you see for a cylinder. And that's basically what a disk is a cylinder. That is what a disk is. So yeah, just elaborating on that a bit. And that's a way to remember that this is what a ring is. The moment of inertia of a ring. So all it's asking for is the rotational kinetic energy. So that's one formula. And we saw that formula to be K sub R equals 1/2 I, so I here is moment of inertia, and then it was omega squared. I can double check that just to make sure, but yep. So we're actually already given omega, and we're given the formula for moment of inertia. Or sorry, no we're not. We actually have to remember that. But if we remember it, then the rest is pretty straightforward. We can just go ahead and plug everything in. We have all our variables. So let's do that. So I equals 1/2. Our mass is 12 kilograms. And then our inner radius was 0.28. And then our outer radius was 0.33 meters. So that's all the values, and now all we have to do is plug that into our calculator, and we should get f of 12 is 6, and then times the radii. And we get, we get 1.1 23. So we're gonna round up here. This is 2.4, and this is, let me remember, it's kilogram meters squared. I always forget the units for a moment of inertia. But yeah, kilogram meter squared. Right, we have mass, and then we have a meter squared. Yeah, it's essentially what it is. Okay. So that's how you can remember the units. So yeah, we have that value, and now all we have to plug in is our omega, and we're done. This is a very simple problem. Promise I'm trying not to take it, make it last too long. So yeah, let's go ahead and plug in everything. K sub r equals 1/2, and then I was 1.24, and our omega is 120 squared. So let's go ahead and calculate this. So when we're all done, when we're all said and done with that calculation, we find that we get a kinetic energy of 0.91 times 10 to the 3 joules, and this is this represents our rotational kinetic energy, and this is our final answer. So yeah, if you found this video helpful, it's very straightforward. You just found the moment of inertia, you remembered that, and then you wrote down all your known variables, and then you just looked at the formula sheet and found the rotational kinetic energy formula and plugged everything in. So yeah, if you found it helpful, make sure to leave a like and comment down below if you need help. And that is it. Thank you so much for watching.